Alright, last video for lesson 7.3, and that is going to be quadratic word problems. So let's say that you have a golf ball and it's hit with an initial velocity or a vertical velocity of 80 feet per second. And this is the quadratic equation that models that situation where h is the height at any given time. How high is the ball after 2 seconds? Well, seconds is time, so I know that t has to equal 2 seconds here. So all I would need to do is take this value of 2 and plug it into all values of t in my equation. So I know that the height will be equal to negative 16 times 2 squared plus 80 times 2. Okay, all I've done there is I've rewritten this quadratic equation, but instead of writing the t's, I've written 2's instead of. Alright, so I'm just going to go to the calculator and do negative 16 and then 2 squared plus 80 times 2. And I get 96. So the height, h, is going to be equal to 96 feet whenever t is 2 seconds. Alright, let's go to part B. It says, how many seconds would it take for the ball to hit the ground? In other words, if the height is equal to 0. So if I know that h is equal to negative 16 t squared minus 80t, should be plus 80t, then I know that I can plug in 0 for h and solve. Okay, now I don't have a constant, so I'm just going to call that 0. So now I can label negative 16 is A, 80 is B, and 0 is C. So I'll come over here and say that. So A is equal to negative 16, B is equal to 80, and C is equal to 0. So my quadratic formula is going to be negative b plus or minus the root of b squared minus 4ac all over 2a. So b is 80. So I'm going to plug in an 80, and that's going to give me a positive or a negative 80 plus or minus the root of 80 squared minus 4 times a, which is negative 16, times c, which is 0, all over 2 times negative 16. And at this point, I'm just going to go to the calculator and let it solve that for me. So we'll do n over d, negative 80. We'll do plus the root of 80 squared minus 4 times negative 16 times 0 all over 2 times negative 16. And this is going to give me 0. So I know, and that makes sense if you think about it. Okay, so what did we just solve for? Where h is equal to 0 feet. Okay, so that makes sense because at some point when I plug in and set this equal to 0, the time is going to be 0 and the height's also going to be 0. Well, let's find the other 0. Let's go highlight it, and instead of putting in a positive here, we're going to put in a negative. And so that's also where h is equal to 5 feet. So there's 2 places where the ball or the height is equal to 0 at time 0 and also at, oh, did I just do the wrong thing? Nope, I said height here and I meant, this is not right. So sorry. We solved for t because we plugged in 0 for h. So t, time, is going to be equal to 0 in 5 seconds. That is my bad on that one. Yeah, t is equal to 0 in 5 seconds. And think about why that makes sense, because the height is going to be 0 when time is 0. That means it hasn't been sent off into the air yet, and then it goes in the air and then it comes back down, hits the ground, and at that time the height is also 0. And it makes a little more sense to plug this in to Desmos. So let me open up Desmos. So this problem shows us having, let's see, negative 16t squared plus 80t plus 0. Negative 16. We'll do x squared plus 80x. So you'll see that makes a little more sense here. The ball goes up and then comes back down. And we're going to use this one here. I'm also going to type this in as y is equal. In the problem, we would have had h, but it's okay to use x and y. Desmos is not going to understand what h is, or it's going to get confused on that. Okay, so let's go over here. Okay, so then now I'm going to actually use this to answer this last question without even using the quadratic formula for part C. But if you did want to use the quadratic formula for part C, think about how you would set it up. When will the ball reach 48 feet? So the last problem asked us to set it equal to 0 because it wanted to know what the height was whenever, or what the time was whenever it was 0. But now we want to know what the height would be, or what the time would be whenever it has a height of 48 feet. So instead of plugging in 0 for height, we're going to plug in 48 for height. Okay, and you can subtract 48, and that's going to give you negative 16t squared. Oh, this should be a t here. Plus 80t minus 48. Okay, and this would be your A, B, and C. And I know that last time I did I made this a positive, and you can do that by switching the sign on all of those. But you should come to the same answer either way. But a more intuitive way to actually see what's going on is to just come over here and into Desmos and type out as y is equal to 48, so you can see what's going on here when you zoom in. Whenever y is equal to 48, you're going to have a time of about 0.7 seconds when y is equal to 48 as well, so the ball goes up, and at time 0.7 or 0.697, it's 48 feet high, it keeps going, and then it comes back down, and then after 4.3 seconds, it's also at 48 feet again. And so that's not a nice way to be able to see where those actually come from. But you can use the quadratic formula to solve for that. And we can do that real quick. I'll just plug it in the calculator for you to see. So we have A, B, and C, so that'll be n over d. We'll do negative b, which is negative 80, plus, we'll do the plus first, the square root of 80 squared minus 4 times negative 16 times c, which is negative 48, and that's all over 2 times a, so 2 times negative 16. And you'll see we did in fact get the same thing, 0.69. I'll drag this right over here so we can save that. And then on the other side, whenever I go highlight this and change this plus to a negative here, you'll see that we did in fact get the other value. So 4.30 and 0.697, same thing on those. All right, well, hopefully you are starting to kind of get the hang of this. I do encourage you to go try those U-tries on the previous videos, and then otherwise you'll probably have a Delta Math that we're going to do, but I will see you in the next video.